that's not, I mean, so the phrase for my generation is you suck it up.
Oh,
Like, oh, I don't feel very good. I have meetings. I'm just gonna suck it up and go.
yeah.
Where now it's I'm gonna thug it out. That sounds better, the thugging it out. Very rarely do I think the modern sayings of things sound better than the old sayings. Um, well, it's not that common. I mean, usually older people look at the newfangled, phrases and like, oh, that's stupid. Why did they have to change it? Blah, blah. I'm sure my parents did the same thing. Huh?
There's no.
Well, like, yeah, my nephew says like instead of you got it or whatever, it's bet. It's like bet. Who came up with that? And then who decided that it meant what that said it meant?
Oh, that makes perfect sense.
How?
It really does. It's like bet. You're gonna do that.
Like I
Like take a bet.
But why you take a bet if you're just agreeing to go to something? Why don't they just say agreed if they wanted one word?
I'm trying to give a good example.
Yeah, you're not going to find one.
And
Yeah, I'm trying to come up with a good example. You're not going to find one.
It makes so much sense. Like,
let's see what
no, it sounds like a short version, like you bet. Like you say, like let's go to the park. Like you bet. Let's go to the park.
bet is a
It's like
widely
bet.
used slang term, primarily meaning yes, I agree for sure, or okay.
No, and that's fine. I mean, so I've gotten used to it. I think that now that I've heard it used and I understand the context enough many, many, many times over a while, I get it. I don't have a major issue with it. But yeah, I don't know.
So thugging it out would imply buckling down and doing.
No, just like sucking it up. Like, okay, I can call in sick or I'll just suck it up and go to work. I'll thug it out. So I like that. That feels like an upgrade to me. Bet does not feel like an upgrade.
Bet is
All right, am I recording?
don't worry, everyone is
Yes. Yeah. All right. So shut up. Carnival, you're here. You oversleep? Oh, what's the drink? Is that like a children's mocktail? What do they order? What do they order at I hear the parents on the cruise ships at the bar, they come up and they what's it called?
Shirley Temple's good, bro. I don't even want to.
what's the other name for it? Like it's like
It's a Shirley Temple.
Kitty cocktail?
Yeah.
That's probably how he orders it. He orders it as a kitty cocktail. And then the parents who are trying to connect to their kids, when they order theirs, they order it as a dirty Shirley.
no, yeah, that's
There's
nasty.
no way.
100%. It's a Shirley Temple with real booze in it. That's a dirty Shirley. What? Just because it has booze in it? Yeah. So I can mention anything and put booze in it, and all of a sudden it sounds good. Does anybody actually like the taste of booze? Yeah, it's
Just get rid of the mixers and just go straight into it.
well, that'll make you get less full, but it'll make it less drinkable. That's why some of these new things have become popular, like I don't remember the name of them, but they're these little tiny, like, I think it's like a fruit flavored thing. They're kind of in a ball format. And huh? Is that what they're called?
Yeah.
Are you even 21? Should you know what buzz balls are? Oh, I saw your eyes. You drink them. This is all recorded. This is all recorded too. So here we'll throw in a don't drink on campus. So now it's completely official.
It was constant. Can you drink beer?
No, look.
I believe,
That's how it is in Texas.
yeah, I believe in Wisconsin, you can have beer or wine with your parents' consent if your parent is there.
Yeah,
Is my understanding. But I've been here since 2006 and I can't tell you that I've ever seen one example of like a parent and a kid coming up to, you know, a bar at a restaurant and the parent ordering a beer for the kid.
Oh,
Yeah, but I mean, I just haven't seen an example in the wild. Well, the same as the is in the rest of the United States, 21. But there's some special rules that allow for a parent, I think, can order a beer or wine for their kid. I don't think they can order a whiskey. Yeah.
Do you remember the time when it was different? When the drinking age was different?
It's been 21 my entire life. So, yeah, so I was born in 1978.
He was not here.
I was born, I grew up in Champaign, Illinois.
That's right.
So basically similar state.
I think in the eighties it was 18.
That's possible.
Rules against drunk driving.
Yeah.
At the federal. Right,
Yeah, it's possible. Yeah. All right, so let's dive in. Today we're working on some more JSON stuff, right? Let's see where we left off last time. I think I gave you a starting point for the assignment, right? Oh, cruise ships, file IO. Oh, that's right. We were doing Carnival Cruise Line. Perfect. Perfect. All right. What do we got so far? So we got a file called ships.dat, which is just a comma delimited file with a whole bunch of Carnival branded cruise line stuff in there. We have our driver file. What does driver do? Driver reads in the stuff from that file. So we create a file object, giving it the name of the file. And since we're working out of the current directory, we didn't have to give it a full path, but do take that as a little bit of a warning, depending on your setup. And frankly, I expected the setup here and open GDB to, or is it online GDB to maybe be worse and give us an example of this. But sometimes when you're using online systems like this, in order for them to produce the experience they're giving us, they've had to take some liberties behind the scenes on like mapping the code to a directory structure. So sometimes what you think is your local directory might not actually be the local directory. And so if you're ever writing code in a situation like that, like maybe Notebook LM might be something similar, or Jupyter, whatever, you might have to give it a full path to where your file lives rather than just say, hey, here's this, or a / saying, look in the current directory. So if it doesn't find it, that's probably what's going on. So just throw that in the back of your head as like a warning. That's not a super uncommon thing. But we're reading it, so we're associating an object with that file. Then we're associating that file with a scanner. And remember, scanners we've used before to help us read crap in from the user. All right, so now we're reading stuff in from a file. So then we have we saw that we actually read it in all as one string, doing it this way. It could be the nature of our data, because our data is showing up all as one string, where if we had a bunch of \ns in there where it kicked everything down a line, it's possible we'd have to read from this file 50 times, one line at a time. But we saw this is all coming in as a string, so we didn't have to do it in a loop or anything. We just said, hey, if there's something to read off that scanner, go ahead and read in that entire line. So that would be all the ships. And then split that on a semicolon. All right. Because what we did is, if you, in our data here, we had all the information about a ship, comma separated, but then that ship separated from another ship by a semicolon. All right, so that's why we're splitting on semicolon. All right, so this is going to give us an array of strings, where that array of strings, this will be like an example of one string. Ay, ay, ay. I guess I'm going to have to use the magical keyboard. My mouse skills are lacking today. So one string might be like that. One of the buckets of the array will contain the string that is Carnival, Panorama, comma, 133,500, comma, and then 5146. So that's the gross tonnage and the maximum passengers. Those are the pieces of information we have there. So that'll be each string inside of that array. So The parts will hold a whole bunch of strings, one string per bucket. That is a comma delimited line. So then we wrote a for loop that goes through each of those strings. And for each of those strings, we created a cruise ship. And if we remind ourselves a cruise ship object here, we're keeping track of 3 different fields. We're keeping track of the name of the ship as a string, the gross tonnage as an int, and the max passengers as an int. Those 3 things. So when we build our cruise ship, we look at driver here. Here's our constructor for our cruise ship. We are passing in one of the strings. That is the comma delimited string. That's what we're passing it. So that's what's coming into the constructor here. What are we doing with that? This time we're going to take that string and we're going to split it on commas to get our 3 individual parts. The name will be bucket 0. The gross tonnage will be bucket 1. Number of passengers will be bucket 2. In there. All right, so that's what the parts will be. So then we'll go ahead and say ship name is going to be equal to the parts at bucket 0.trim. .trim takes off any white space on either end. Every language will have an equivalent of that. Clean up the string so it only has the data part of it. That type of thing. So we'll get the ship name straight up because it's already a string. When we split a string on something, what we end up with is a bunch of strings. Even though in this particular case, if we look at our data, we see that if we were describing this, this is a string followed by a number, followed by a number, right? Just our eyes looking at it. But when we read that in, that whole thing is coming in as a string. So when we split that on commas, we're going to be set up with a string, and a string, which is why we have an array of strings here. This guy's an array of strings. So our ship name, which is going to be a string, we'll just take whatever's at that bucket and trim it so there's not extra stuff on it. Now, when we're setting the gross tonnage is an int. That's the type that gross tonnage is. So to get the int out of that, we're going to take our string portion of the thing, which is going to be our gross tonnage number, 155,000, whatever. All right, we're going to take that number currently represented as a string. So double quote, 155,000, double quote. That's a string. All right, we're going to take that string and we are going to parse the integer out of it. All right, now if we went into the documentation, specifically the integer class in Java, and we saw that there's a method in there called parseInt. And parseInt, if you're looking at how we're calling it here, we're calling it using the name of the class in which the parseInt method was found. That means that parseInt must have been a static method, a static member of the integer class. Static members are owned by the class themselves, which means that when we go to use them, we need to use the class name to access those static members, not an instance of the class. All right. So in order to take any old string that we happen to know is a numeric, don't try to convert hello. Don't do integer dot parseInt on the string hello. It will yell at you. Hello is not a numberable string, right? What would you expect to get if you tried to juice the integer out of hello? If you can't expect anything as a smart human, don't expect this dude to come up with something helpful. All right, so we know this is going to be the string representation of a number. We'll go ahead and trim it to make sure there's not any white space on either end. I don't think we have any reason to believe there would be here. I would just suggest that it's somewhat common practice. Just say, hey, it cost me a couple of extra characters. Who cares how hard I'm making the computer work because this is all set up stuff. Just make sure I have a clean string, whether I needed to do this or not. I would say that's probably more common than to go back and look at your data source and decide what format your data source is in. A lot of times you might just assume that your data source might have some level of corruption in it. maybe one extra space somewhere or something like that. So I would say it's pretty common practice to just do a trim as soon as you uh, uh, grab the data just to make sure it's clean and just assume it might not be. Go ahead. Well, so if I have the string representation of this guy. So this is we can look at that as a human and say that's a number, that holds a number. But because of those two double quotes, as far as Java is concerned, that's a string. When I say integer.parseInt on that string, I get the number 32,000. What is that a 3? 32,346. I get that now as an int. An actual true that it's now an integer. That's the kind of animal it is. It's no longer a string. So now we can do like mathy stuff with it. Because if I use the plus sign with a string, it's going to be treated as concatenation, right? So the 32346 plus 1, for example, will be, what's the answer to that? What will be the outcome of that little math formula there? Nope, no error in this language. Python would give you an error. Why would Python give me an error here? So Python has multiple uses for the plus sign, right? Just like Java. The plus sign, all our lives, we viewed that as a mathy addition thing, right? You take two numbers, you add them together, that's addition. Plus signs used for that. Well, now as computer scientists, we've learned that the plus sign has also commonly been used that wheel is very lucky it survived that. I know I seem petite, but in real life I'm quite large. Man, because I would just bend the crap out of that. I've broken steel chairs before. But those hinges are weak, especially at those weddings. I got to spend an entire wedding with my feet planted, like holding a third of my body weight so I don't snap the chair, embarrassing the whole, like ruining the whole thing.
Not you.
And whenever we have things here on campus, where we have to march in our whole rigmarole, if you go to graduation, you get to see my doctoral gown. I got zeros and ones all over. It's pretty awesome. Yeah. But I mean, only I could pull that off because I could pull off Fred Flintstone here.
Yeah.
So it's a thing. But yeah, when they seat us, I get our row always has one less human count because I get a double seat.
It says one less human count.
Well, I mean, I've been here since 2006, so there are professors who've been here longer, but I'm in the top, 10% probably. So they all know me. They all know that I embrace my size. I need a little bit larger seat. It's just the reality of the situation. All right. So in any case, how did we get from the plus sign to me being fat? Stepping on the thing. That's right. All right. So if we have a string followed by a plus sign in Java, if a plus sign is there and a string is on either side of that plus sign is now treated as the concatenation operator instead of the addition operator. So now it's going to expect one of the sides to be a string. Python has a little bit stricter view on the plus sign. Python says, look, I see a plus sign. If you want me to treat this as concatenation, both sides must be of string type. Yeah, it is, but that's not the rationale for why they have that decision. That decision is just how do you determine that this is no longer addition? Python requires both sides to be numbers. Java requires Python requires both sides to be strings. Java requires only one side to be a string. In Python, if you only have one side being a string, you'll then get an error. It'll yell at you and say that the plus side, and that's reasonable. I mean, I can agree with that. Yeah, I mean, no, I mean, I can roughly agree with that. That if we're going to make a decision, if you want to have one symbol serve two purposes, be math addition, but also be concatenation. I don't think it's unreasonable to say, look, if you want it to work as concatenation, give me two strings. I think that's reasonable enough. And if you want it to work for addition, give me two numbers. If you give me any different combination, I'm going to scream at you. I mean, I agree. That seems reasonable. No, I don't have a major problem otherwise, but I think we can make the argument that this is more of a convenience for the programmer where, hey, yeah, you obviously mean concatenation since you've thrown a string in there. So I'll go ahead and treat it like that. So in this particular case, since there's a string involved in Java, it's going to give us the 3, 2, what is it? 3, 4, 6, and 1. It's going to give us that as an answer. It's not going to do math. It's just going to concatenate the 1 onto the end because the plus sign is treated as the concatenation operator. We want math. So you asked, what does parseInt do? ParseInt turns that guy into an actual number. So now when I do the math, I'm adding 1 to this, so this would be a 62. All right, so parseInt lets me take a numeric version of a string and turn it into let's see, I'm missing a comma here. Don't give examples in the middle of your data. All right, so yeah, that's what parseInt does.
Fix the space. I should know.
Yeah, I have that's the reason we have the trim. Although I think split probably takes the spaces out. So you are at the mercy of that. If you use split or whatever the language's version of that is to take a string in a certain format and split it on a what's called a regular expression, but we usually just do a delimiter. So you can actually split on pretty powerful things with regular expressions. You could teach probably for a couple of weeks on regular expressions at least. So regular expressions themselves are almost, it's like a little mini programming language for describing a pattern within a string. So you can describe like complex patterns. Like I'm looking for these 3 letters followed by a plus sign, followed by at most 8 numbers, followed by, like you can describe very complex data and say split on that. Or we're just saying split it on the comma. 1 comma, find a comma. All right, so in any case, here we'll get the numerical version of the gross tonnage, and we'll store that inside of gross tonnage as an int. We'll get the integer version of the number of passengers. We'll store that inside of max passengers. And then we gave ourselves some getters here, blah, blah, blah. Oh, it looks like we already wrote some JSON stuff. Okay, so what did we leave it at? All right, so we got that, and then we printed out the JSON version of all that. So when I run this now, it should go through my entire file, split it on semicolons, then go through each of those semicolon strings, create a cruise ship out of it by parsing out the 3 pieces of information, and then outputting the JSON version of that single JSON object. All right, so this comes back to what you were talking about, Carson, is so JSON follows a format. JSON exists as a JSON object. So if we were to describe JSON, I thought we did this in did we do this in the slides?
Like where you gave us.
Yeah, so if we say JSON, anybody remember what JSON stands for? JavaScript object notation. JavaScript object notation. All right, so that's what this guy stands for. And JavaScript, or I'm sorry, JSON is a JSON object. So JSON at the top level is a JSON object. Now, JSON objects come in 2 flavors. We have a flavor that is we'll call it a standard JSON object. So this is the guy that starts with an opening curly brace, ends with a closing curly brace, and then has comma, delimited, name value pairs inside of those semicolons. And we can go here and say, think dictionaries in Python. So a normal standard plain Jane JSON object, like I think we're outputting right now. So if I go ahead and run this. Am I on the right thing? Okay. So go ahead and run this. We should have a bunch of JSON down there, I think. Okay. So for example, this guy I have highlighted right here. So this is an opening curly brace, a closing curly brace at the other end. So that's a one form. I'm going to call that the standard form of a JSON object. And then inside of there, we have comma delimited name value pairs. Ship name is Seaborn Quest. Gross tonnage is this number. Max passengers is that number. Those are the name value pairs. Okay, so this is very similar to how dictionaries work in Python, as well as in JavaScript, actually. All right, so that's one form of a JSON object. We'll call that the normal form. Now, the other form of a JSON object is a JSON array. And a JSON array is opening square bracket, closing square bracket, containing comma delimited JSON objects. Or a JSON object can be a standard JSON object or a JSON array. So you can just keep going down the path. All right. So this describes JSON, these two lines, three lines with the example. All right. So here's a whole bunch of individual JSON objects. What was the homework assignment? What? Oh, write out the JSON, the JSON object for this. Okay. So we're always good.
So, where every line I put a comma after the curly braces.
Yeah.
So after every curly brace, I put a comma. And then at the very last line, like we have highlighted, I didn't. I would
Yeah.
put that as like
Comma delimited name value pairs, comma delimited JSON objects. Yeah, so you won't have a comma at the after the very last one, because that's the end of your object. You're not delimiting another thing. Yeah. So let's see how we can do this. So the homework was to create a output file, cruise ships.json or something. Did I tell you the name? All right, whatever. All right, so basically we're creating an output file that we're going to write out to that works. So we're converting this rough data into what we'll call usable JSON data. All right, so now I want you to think about the skill set we're doing here. This is, I mean, between last class and today, super powerful skill set. Because what did we do? We went on to, in this case, we went on to AI and asked a question. Told us to give it in a format. Now, we probably could have asked for it in JSON format. It would have done it for us. But you're not always going to have that luxury. You might not ask AI. You might go to some site that has a CSV file that has your data in it. And you now need to take that and turn it into other data. Now, sure, there's probably a Python library that says, take something from any format under the sun and turn it into something. That's what makes Python so powerful, is you don't have to write little things like this. But I know how to write things like this. That's an important piece of that, because now you have the chops to go and solve a problem that maybe Python doesn't have that library for. Or, frankly, Python has a library for just about everything. Or your data doesn't quite adhere to a standard format, where you really need to write something a little bit special for fairly janky data. Working with janky data is pretty common. Is janky still the word? Do people say that today? You've never heard janky? Like, oh. Okay, well, so in any case, one of the skills in like data science that you might look at, and also machine learning, because machine learning came out of data science. And frankly, if we're going to keep patting Python on the back, Python was probably the pathway for that. And this is for the same reason why I dislike Python, is what Python allowed. Python has so much stuff built into it that it allows the non-programmer, so these data science people. Now, non-programmer doesn't mean stupid. It just means the focus of their vocation is not sitting there typing out code, it's something else. You know, they have some other strong thing, but the code aspect of it used to be a barrier for them. A data scientist person either had very limited ways of working with data directly, or had to partner with another skill set to maybe clean the data up for them, get it in a certain format so they can work with it. Well, now Python has added a lot of stuff. It's almost like what AI has now done for us. Python kind of did a structured version of that for the data science people so that they can take things in all sorts of different formats, and get it into like one of the main libraries that came out years ago for that is called Pandas, that allows you to just clean up data that looks like crap, uh, because it allows you to describe your data. And so what you have a lot of data science people do is they go out and they get a working program, they copy it in, and then they make the changes based on what their data set is and stuff like that. But Python has allowed the non-programming skill set to accomplish certain programming skills like cleaning up data. So really, the cleansing of data is a major part of data science. So we shouldn't assume that that's not there to begin with. Well, anyways, so we are going to be outputting here. We're going to be creating a file. So we want to start off with, can I write to a file? So let's learn how to write to a file. All right. So I don't think I gave you any of that information, right? Okay. So we need to be able to write to a file. Now, when we display something, how are we displaying? How do we write something out? We already use a scanner to read something in, right? So now we're just kind of, I'm putting myself in your shoes, as you didn't have any starting stuff to work with for writing out to a file. You have stuff for reading in from a file, but the reading in from a file used something that you've used before, scanner, right? But so when you write something out, what are we familiar with for writing something out in Java? Yeah, system.out.println. That's how we get something out to some location. So let's go and look at the documentation for println. Now, in order to get to println, we need to be able to find this guy. So we're going to start off with the top level thing. System starts with a capital S, probably the name of a class. System.out, no parentheses on out. So out is probably a field. Specifically, it's a static field. Why? Because it's being called with the name of a class. So if we go into the system class, we should find a static field called out. And that guy is going to be an instance of some class, I think it's a print stream, that has a function in it called println. And if you remember, there was a whole bunch of different versions of println in there that knew how to do all the different types. So let's go and chase that down and see if there's more than one way to create a print stream. See what we figure out there. So I'm going to search for Java system class. Okay, so we get this guy. All right, so right off the bat, here's our out. This guy's a print stream, and notice he's static. Okay, so we were able to predict that by looking at the code in which it was used, right? Super important skill to be able to go back and forth with documentation. Not only just knowing that knowledge, but also getting into the habit of looking at the code and being able to determine, what am I looking at structurally? Even if you don't know what the line of code actually accomplishes because it's using some function you've never used before, the function probably has a name that's somewhat meaningful. But bottom line is you can still learn a lot about a line of code without having ever seen it before. All right, so we get into this print stream thing. Okay, well, we know that system.out.println lets us display stuff to the screen. So let's look at this print stream. This guy's already been created. So whatever system.out magic needed to happen, connecting it directly to the standard output stream of the file. And we've seen this before. I've talked about system.out, system.err, and then system.in. So system.in is our input stream. It's what we've used with Scanner to pull things into our program. Now we've used a different input stream with Scanner that allowed us to connect it to a file, right? So we've used Scanner for reading in from multiple different types of streams. System.in was one of them, the standard input stream, the keyboard, and the output stream, or the input stream associated with our file object got used when we created our scanner with a file. So now we want to create something that will write something out. So we're going to probably be doing the print stream stuff, not the input stream stuff. So let's click on print stream. Let's go down and look at the various ways we can get print streams. Remember, we are writing a print stream out to we're hoping to write to a file. Okay, and oh, look at that. Right there at the top, this creates a new print stream without automatic line flushing with the specified line. Without automatic line flushing can be an important thing. So let me just throw a little trivia thing for you to put in your notes or something. When something is talking about flushing, notwithstanding Carnival's bad experience, you were on that ship that made the Netflix special, right?
Yeah.
What was that called? The poop cruise? Huh?
Please tell me you're good.
No, it was a famous thing. They've made a bunch of changes to the cruise, the ship design since, but there was a series of events that happened on a cruise ship that could have happened on any ship. This isn't like a bash on Carnival. It just, there was water, there was electricity. These two things were too close to each other. The whole ship was basically dead in the water, including their all their sewage, dealing with sewage systems. So all the rooms began to overflow with stuff you don't want to be your room overflowing with. So everybody moved out onto the Lido deck and joined him. He's been sleeping out in the deck chairs for months. All of a sudden, he's got competition now. They created like a shanty town on the Lido deck because they couldn't go in the ship. It smelled so bad. No. Well, there's been fires on ships, but yeah.
But it's just the sewage just went terrible.
It was bad.
Look, you know, for that.
Well, how would I be there if it was a Carnival ship? I would have been on a celebrity ship watching that ship. You know, we'd be taking pictures of the shanty town. I was on the if you remember at the very beginning of COVID, there was a famous COVID ship that was off the coast of Japan. You know, the one that they wouldn't let them onto land, so these people were trapped on the ship. That was the Diamond Princess from Princess Cruise Lines. So once they closed Japan during the pandemic, that ship moved to San Diego and started doing cruises to Hawaii. So my wife and I, as soon as the cruise industry kind of opened back up, everything, you still had to wear masks everywhere and stuff. But we went on the Diamond Princess. The first time I had COVID was on the Diamond Princess. I was sick for one day, and then I wore my mask everywhere, but I drank through that. It was fine.
So,
There's no virus that could stand up to the amount of alcohol I was putting in the system. Just wiping it off the face of the earth. Some of Trump's plans only work in heavy bulk. Really had to get in there. All right, so there are going to be different ways you can get to this, but I promise you, at some level, they're all going to use the same subsystem under the hood. Because even think about this, how much is being abstracted from us. We're saying, okay, I'm going to create a file. So let's go do that. Let's just follow the instructions here because we've done this already, right? We had come into our code. Oh, hold on. I'm already in my browser, right? Why do I have so many tabs?
I think compared to what most people, I would think you're. Oh, never mind, take it back.
When you're minimizing folders in your tabs, you've hit rock bottom. I'm going to online GDB. Am I there? All right. This is a purple logo. All right, so if we go back into a driver here where we did it previously, we created a file previously by reading in from our file, right? All right, so let's go ahead. Now, what I'm going to do is we have our cruise ship data and we're using it, we're passing it the information. Actually, let's do it out here. I was going to go a different direction. So since we know that we could have some error type stuff, exception throwing associated with, we had a file issue like this before where the file might not be found. Well, it might not be found when we're reading it in. It might not be found when we're writing it out. But when we're writing it out, we want to we want to overwrite whatever was there before. So we'll deal with that. Okay, so I'm going to go ahead and I'm going to say file output. We'll call this output file is equal to a new file. And what do we want to call this? Ships.json? Cruise ships.json? Like that? All right, kind of. We'll call that good. Or did I do camel case? All right. By the way, this is called camel case. If you heard that before and didn't know what they were talking about, start off with a lowercase letter at the beginning, and then your syllables become uppercase letters. Humps on the camel. that's camel case. All right. All right. So I'm going to read in this file called cruise ship. I'm going to create a file called cruise ships.json. Chances are, if I go into the constructor for file, let's just confirm this for our own mentality, but it's probably going to tell me that it'll create the file if it's not there, and it might tell me it'll either overwrite the file otherwise, or let's look at the different constructors I have for file. I might get to choose. So here's print stream. We'll go ahead and click on file. For that, and let's go look at the constructors of file because that's what we're using right now, right? All right, so we have four different ways of creating a file. We can create it with just the path name. This is the one we're using. So creates a new file instance by converting the given path name into an abstract file name, blah, 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 whatever that means. Let's click on it. Does it tell me? So it'll give me the path, but will it, well, let's just find out what it does. I was hoping this would tell me if the file didn't exist, what it would do, but I think the default behavior is going to be that it will, is that the chair became uncomfortable for him? The default behavior, where is it? All right, got it. All right, what? I have another one? No. Oh, you think I have it inside of CUW here?
What are we looking for?
My GDB thing. Do I have more than one? Well, I am, but this isn't the code I was just looking at. Well, cruise ships file IO. All right. It has our stuff. I must have just hit the back arrow or something. All right, so we'll get our file and let's just practice writing some stuff out before we start doing anything major. So we're going to create our print stream off of this guy using our file. So we're going to say print stream PS is equal to a new print stream, passing it my output file. Now we are doing all this inside of our original try catch. So if any exceptions get thrown, we're going to just catch those right here and just print out the exception. So we're not really doing error handling. We're just trying to make Java shut up and just assuming everything will go smoothly. So I'll create a link to my file. If the file's not there, I believe it'll create it for us. We're going to create our print stream around that. So now we already know how to use print streams. Println, write something to it. And so I should be able to say ps.println hello, ps.println world. All right, now good programming practice would be to close a file when you're done using it. Most languages will close it for you. But if I go back down to file here, somewhere in the code up here, there's going to be a close probably. And next to you can read, delete. Oh, there's going to be something. Oh, there's not. You're right. Hold on. Wait, actually, let's see who he inherits from. Methods inherited from class object. Yeah, there isn't a close. Maybe on the print stream? Is there a close on print stream? Am I in print stream right now or are we still in file? I'm still in file. So here's print stream. Saw close. Would it be up in the, okay. This closes the stream, which must close the file, I suppose. The underlying link. So I would always go into here. Is at the very end here, I'd say ps.close, even though you probably don't need to in any modern language. It kind of falls into that same category we've talked about with the automatic garbage collection. We also used to have to clean up any memory we asked for, which would mean every single time you use the new keyword, somewhere else you'd have the equivalent of the new keyword in C++, the antithesis of the new keyword in C++ would be delete. If you go back to a little older language like C or Objective-C, it's dealloc? I think it's deallocating the memory. We don't have to do that as much anymore. The languages do it for us, but I still think it's good practice to do it. All right, so we'll go ahead and run this. What we're hoping is in the end, it creates a new file for us, cruiseships.json, and we get a hello world in there. Let's just see if we're able to write to this guy. All right, cannot find, okay, so print stream lives inside of java.io. So it lives inside of a different library that we didn't tell it about. So it's saying, hey, I've never heard of this guy. So we're going to import java.io.printstream and go ahead and run this again. So now he's heard of that guy. All right. So now we see that we have a new file, cruiseships.json, and we have some stuff in it. Pretty good. All right. So now what I'm going to do, I'm going to leave that file there. And now we're going to add a woot and an LOL instead. But we're going to leave the file alone. We want to see what behavior do we have when we try to write to a file that already exists. Am I going to overwrite that file, or am I going to create or just add to that file? So there's my LOL and my woot. It overwrote that file. Now let's just make sure it's overwriting the entire file and not just as far as it went into that file. So I'm going to go and I'll change this guy back to hello, and I'll take the second one out. So now it's only writing one thing. So we're either going to have just hello or we're going to have hello, then woot. Because if it opened the file and started it at the very beginning and just start overwriting as it went in, So we're just basically dabbling until we understand the behavior of the writing here. Okay. More than likely, it's going to always completely overwrite the file. There's a way of opening this file saying, I want you to append to this, but we didn't do it that way. We opened the file the generic way. So I believe we're probably going to have a file with just hello in this when we're done running it this time. Call it 97% certain. All right, so there's our hello. That's probably the way most languages work, is when you open a file that already exists, it overwrites that file unless you specifically tell it not to. So that's usually the default behavior. It'll probably be somewhere in file or somewhere in print stream where you're telling it to overwrite it. We can just look real quick. We still have print stream. That's a character set. Here's an output stream with a Boolean for auto flush. Auto flush is something that's probably less of a problem today, but when you are, and it's not really a problem with file IO, because remember, we're dealing with print stream, which can be associated with any sort of input or output stream. All right, well, print streams would be output streams. So that means we might be writing to the screen. We might be writing to a file. We might also be writing to a socket, an internet socket that's going across the internet. So if you want to write a program that's here and a program that's running right there across the internet, right? He can have his program set up to listen for an incoming connection over a socket. I can then connect to that listening socket so that he would create something called a server socket. He's the server in a client server model. So he would be listening on port 5000, let's say. He would pick some random port that is not being used on his computer so we can investigate into which port that might be. But 5000 is probably safe since I'm guessing you don't run a lot of servers on your computer. So he's got port 5000 listening. I write my program to open up a socket to port 5000, his IP address. And then it's going to open up that socket, and then I can ask that socket for its input and output stream. So I can build a print writer using the output stream of an internet socket. Still a print writer. I still write to it with println. I'm either writing to the screen, I'm writing to a file, or in this case, I'm writing over an internet socket. He has to choose what to do with it because my output stream connects up to his input stream. So now he can read from that socket just like we read from a file, and he can do with that information what he wants. So now we just wrote internet programs. All we changed there is instead of a file, we replaced it with a socket. Now it's that socket thing, which is part of the TCP/IP stack. So now we're getting into network things. I'll probably go off on a tangent at some point when we do sockets, so we'll just save that for then. But sockets are notorious for having data kind of get trapped in them, almost like I guess like a clogged pipe with plumbing, and it's usually the end data. So a lot of times what you'll do is after you've written your last piece of data, when you're getting ready to close the socket, you'll do a flush right before you close it. Or when you build it, you can set it up to auto flush where it always cleans out the pipe every single time the pipe's read from, to make sure all data has been read out of it. And ultimately that has to do with the nature of the person reading from the socket. Are they reading from the socket a string at a time, basically saying, I'm going to read as much data as I can that's available there? Or is it reading like one character at a time? Or is it reading, either a byte or if it's a byte at a time and you're passing Unicode, you're actually only reading in half a character of data, right? Because Unicode is 16-bit chars. So if you're reading in bytes, it's going to take 2 reads to get 1 character if you're reading it in 1 byte at a time. So because of the different natures, we treat a socket like it's a can of Coke. There are different ways people drink cans of Coke. You got the chug, you got the big gulps, and you got the little sips. You seem like a little sip guy. Oh my God, I chug it. And man, I'll tell you what, it's like the soda can just disappears in my maws. My mom would be here, my paws. My paws.
I'm like a medium sip guy.
No, you're not.
I am. I don't like it too much, but I also don't like just not tasting it.
Yeah, yeah, you don't wanna just hug it. Don't-
Yeah, but also I think it's like too small to even taste it, you know?
All right, so we now are seeing that we can write out to files. And we're good with this. So obviously we could probably go diving down this hole and see all sorts of different things we could do with file systems and stuff like this, but we're doing some IO stuff. Our programs are getting a little bit more capable now. We can, I mean, now with file IO, sure, we're using it for this purpose, but we can now store information between runs of our program, which means if we run our program and we want to have some data saved so that the next time we launch this program, it reads in that data so we can pick up where we left off. I mean, that just added a whole new dimension to our programs, right? And then now we've even just talked about internet aware programming, and hopefully you recognize that, oh, that's all that is. You're just changing what you're reading and writing from. Okay, now you have an internet aware. In fact, we just wrote a client server program to do this. And now you throw threads in there. So he's running a server and he knows how to do threads. So now instead of it just being one program connecting to his server, now what he can do is when I try to connect to his server, he takes that socket, spins up a worker bee, hands the worker bee that socket and says, go deal with this guy. So that he can come back and listen for another incoming connection. So then he connects. He spins up a thread, hands him the socket, go deal with this guy. So you got two threads dealing with people. So two different people are connected to his program using things that we learned in here, threads and reading and writing from sockets, which we haven't officially done, but you now know how to do it. Make some sense? All right. So we were supposed to basically write out to cruiseships.json the JSON version of our data, effectively giving ourselves a nice JSON file to work off of. Okay, so we want to start off by we know the nature of our data. So keep in mind, the job we're doing here, we're not writing a program to be this generic program to be run by a zillion different people, at least not at this point. At this point, the problem we're solving as computer scientists, wielding this weapon that is a computer programming language. You know, I want you to think about you walk in with a giant broadsword and you're front lines, you're ready to do stuff. So we've said, okay, somebody gave me a bunch of data, okay? And the data is in a format that's not as convenient to deal with or whatever. And so I'm going to take in the data that I have and I'm going to do my magic coding stuff. And I'm going to turn it into a format that is consistent for how programs usually work today. Programs today usually operate with JSON data. So we're going to build our own JSON data, then decide what we want to do with it, how we want to use it. Yeah.
So, like, what actually is our sort?
JSON doesn't say it's sorted. JSON just says that it's organized. The data has metadata associated with it that tells us that, oh, this number, 229,407, is the gross tonnage of a ship named this. So now your data explains itself. We are then going to write a program that uses it. So all we're doing right now is we're saying, look, I want my data in a better format. And the data that I currently got isn't in the most ideal format that I want. In fact, I might want to provide this data to someone else. And this is a super common thing. I mean, the startup company that I created with an oncologist called Kurova, we're applying AI to cancer clinical trials matching. And the first thing that we did, the very first thing that we did is we took clinicaltrials.gov, which is a government website that actually gives you the data in JSON. So it's already in a format that, because it's an API. And I mentioned that most APIs today read and write JSON. JSON is effectively the agreed upon communication language between anything digital. That's today's cool kid, and it's been the cool kid for a while. Before that, it was XML for 5 minutes, which was the same thing, just wordier. But now it's all JSON. But the very first thing we did is we took clinicaltrials.gov, that whole website, and we rebuilt that database. So we probably spent $300 or $400 in various API credits to pull in all of their data, which is hundreds of thousands of records, many of which are now closed trials. And then we rebuilt that data by going through and updating its content to clean it up. So now when we make decisions, we're not operating, we do batch pulls of their data like once a week to make sure we get the latest trials incorporated into our database. But we make all references to our database, which we've already spent the money and the time and the programming to clean up to make it now reliable. Okay, so that's a major part of, and that's a company, I mean, that, got 400,000 in funding for 10%. And a major part of the software was cleaning up data, doing exactly what we're doing here. Good. Huh? We're mostly Python based. Because, and why are we mostly Python based? Because it is a server based software that is working with a lot of different external libraries and APIs, and Python just has libraries built for doing it. Every one of us who's working on this are software engineers who have been doing this forever. We don't need to practice our for loops, but you guys do. That's why Python is a poor teaching language. There's too many, when you look up examples, it says, oh, just pull library X. It solves that entire problem for you. Yeah, that's amazing if you've been a software engineer for 20 years. Now you just see power tools laying all over the place. And if you go into a garage and there's power tools all over the place and nobody's around, you start messing with the power tools, right? Yeah, that's what we do. So keep that in mind as you're going through your software engineering journey, is focus on building your competence so that later on you can use the power tools guilt-free, knowing that you're not replacing competence. You're replacing some of your time, so you have more time to do something else. You get a riding lawnmower because you're tired of pushing a normal lawnmower, right? Something along those lines. You already know how to mow the yard with a push mower. You've had that experience enough times that you don't like it. The beer spills too much and there's not the cup holder. You have to manufacture, you 3D print something, you realize you did it out of the wrong kind of plastic. It starts melting in the sun. Well, I had to 3D print a very specific one because I typically don't drink beer. So I need to have my bottle of whiskey out there and then I had to build a giant straw, so. Well, neither do I, but we already covered that nobody likes alcohol. It's the effect. You like alcohol for the taste? You're the weird guy.
No, I think I have a lot of.
It's my genetics. I was born addicted to tequila. All right, let's. I agree. I believe you. All right, so now we've proven that we can write out to this thing. So now let's go ahead and let's write our JSON object. Now we know that all JSON starts off with a JSON object. So we have to talk about at our top level, what are we going to be? At our top level, we are going to be a standard JSON object. And that standard JSON object is probably going to be called ships. And ships will be equal to a JSON array containing JSON objects, traditional JSON objects. So we're going to go ahead and we're going to start this guy off with an opening curly brace. And we're going to call this guy ships. Actually, it's usually we put quotes around it like this. And then our opening square bracket. So we're saying we're a JSON object. We start with a curly brace. We're going to have, in this case, we're going to have a single name value pair. The name will be ships. The value will be a JSON array containing all of our ships. All right. We know that we're going to end with a ps.println. We know that there's going to be a closing square bracket. Then there's going to be a closing curly brace. And that's going to be the end of our JSON. Everything in between these two things is our for loop of these guys, right? So what we can do is we can take this code here and we are going to put it in here. At this point, we're not storing it anywhere. And as we go through here, what we want to write out is we want to do ps.println. Okay, now we know the very first thing it's expecting here is a JSON object. So we're going to println cs.toJSON, and then we're going to do a ps.println. And we're going to have our a comma to separate these things. Now, if we leave it like this right now, we're going to have an extra comma after the very last guy. And I'll actually go and show that here in a second. So we can go ahead and get rid of this guy. So I'm going to print out JSON object ships is equal to an array of all of the JSON objects. Now, what he's about to ask for is why do we have all this in our for loop? We're going to take most of this out of our for loop. We can do this stuff because we only want that to happen once. So we'll put that before our for loop. All right. And then we are going to make sure that we're only finishing our for loop or finishing our JSON object one time. So we'll put that outside of the for loop. Okay, so now inside here, we're going to go through and build a cruise ship, get the JSON of our cruise ship. We probably want to store our cruise ships in an array somewhere, but let's just solve one problem at a time. So we're going to get the JSON version of the cruise ship we just built, and then we'll tack on a comma. Now, what this is going to do is it's going to build our JSON almost correctly, except we're going to have one extra comma at the very end. So if I go ahead and run this, and I go in here, we have our ship. Probably should have been called ships, but whatever. Then an array. Here's JSON object 1, followed by a comma. JSON object 2, comma, yada, 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 except we have one extra comma all the way down here at the bottom. All right, before we're ready to go. So we want to make sure that we don't put in that final comma. Most JSON parsers would actually handle this okay, but I would never encourage you to leave the comma on the end. So what we want to do is we want to come out here and we want to decide when does this comma end. This comma ends when we are at the end of our file. But the problem is that when we get our parts here, and we are going through, actually, we're going through parts.length at this point. So if we ask the question on this, if we say if I is equivalent to, what's it called? The parts dot length minus 1. That's the last time we're going through this. So we want to keep putting the comma. While this is not true. So as long as we are not looking at the very last time through this, tack on the comma. Otherwise, don't give me that extra comma. So now we run this, we go to our cruise ships.json, and we see that we do not have that extra comma anymore, but we have it between all the other things. All right, so at this point now, we have a JSON representation of all these ships, which we probably could have asked AI to give us, but what fun is that? And we're going to change this to ships. All right, so does that solve the homework assignment?
Wait, what's that? However, what's the next one?
Well, who cares? Yeah. I mean, we're using println. If we don't use println and we just use print, I mean, this will be fine, but it's all going to be run together on one big long line. Although we are doing println for these commas too. So now it'll be all one big line. So there's our, I must have one more println still in there at the top. Yeah, so if you like that better, otherwise you can just have the comma not be the println or something like that and do a println after that. So you could do something like we could have this be a println. If you want this to look more organized, you can do a \n\t to tab that in. That'll do a tab, and this is only for human visualization. Reading this in is not a thing. So if I run that, you'll see now it'll carriage return it and give me a tab. So now it indented this guy. So if you want it to look a certain way, you know, you can do that. We'd want this guy to be 2 tabs, right? So when you go to do your println of your cruise ship right here, you might start off with tab, and then you get your JSON of this. And then what you can do is you can do a print ln of the comma. So that'll print the comma at the end of that line and then kick it down a line for you to do your next tab. And then this guy right here is going to be a single tab followed by a carriage return. So there's pretty looking JSON. Oh, did I not do a carriage return on that guy?
Line.
Oh, I could have done a println too. You're right. All right, so now we have beautiful JSON, just throwing a couple of tabs in there. File IO is not going to care about this. We're gonna trim those tabs right off. So, all right, questions, comments, concerns, bribes. All right, I'll put this link to this code up on whatever Slack or I'll put it somewhere. And then we'll come back on Thursday and we're going to start using this code to do some stuff. All right. Remember, we're going to chapel if you're interested, meeting in the front row in 10 minutes. Then we're doing lunch at around 11:40. We get a big table if you're interested.